So in number 4 here, we see this differential equation that we've probably worked on in class before. What you simply do here is fill out the chart, and we're going to plug in the points into our equation. So let's say at 1, 1, thank you, Mr. Springer, you would plug into the equation and just draw the slope. So at 1, 1, be 2 over 1 or 2. So it's increasing pretty nicely there. So we're going to draw a line, show that. And then whenever y equals 0, since we're essentially doing that for everything, then we know that it will be undefined or just a vertical line. So when does y equal 0? Right there. At 1, 0, negative 1, negative 2. Okay, so that's what you do for A.
And now at negative 1, when x is negative 1, so every time it's negative 1, it doesn't matter what y is, because what happens to the top? You have negative 1 plus 1, so the top would equal 0. So no matter what y is, it's going to be 0, except for that one undefined that Danira told you about. So at negative 1, you're going to be flat here and flat there. Okay, so then we'll just fill out the rest of the chart. This point is negative 2 for x and y is 1. So negative 2 plus 1 is negative 1 divided by 1, negative 1. So we have a negative slope, not quite as steep as that 2 over there. And over here, still negative 2, but the bottom is negative 1. So we have negative 1 divided by negative 1, positive 1. So about as steep, whoops, too steep, something like that. And here, this is 0, negative 1. So x0 would be 1. 1 divided by negative 1 is negative 1, so pretty flat. Negative 1 would be something like this, maybe. And I bet this one's going to be a negative 2. Let's just double check. So that's 1 comma negative 1. 1 plus 1 is 2. And negative 1, yeah, negative 2, okay. So there we are. All right. The part B, you might not know how to do this one, but you can see that it's flat. Oh, we missed a point, didn't we? Let's go back and do that one first. This is 0, 1, right? So we have 1 over 1, it's positive 1. Okay. Let's try that again. A little flatter. So you can see that this thing kind of forms, you have a 0 slope right here. So it looks something like that. Something like that. But it also kind of does the same thing on the bottom, right? So it kind of does that and that. So this is a hyperbola, which we didn't really study a whole lot. So we'll just call that a hyperbola and skip the rest of that. Okay, let's go on to C. C says find the specific solution to the differential equation, given that 2 comma 4, right? So we have an x and a y value, and we have a differential equation up here. So separate the y's from the x's. Let me erase all this junk. Okay, so if I cross multiply, I got dy times y equals dx and x plus 1. So remember, we're trying to solve for y. So we take the integral, both sides, and we get, that's y to the first, so we have y squared over 2. And over here we get x squared over 2 plus x plus some constant. Okay, since it doesn't really matter when we fix the constant, let's just fix it right now. So x is 2 and y is 4. So we have 4 squared over 2 equals 2 squared over 2 plus 2 plus c. Okay, yep. So we have 16 over 2.
16 over 2. So we're going to simplify this basically. We get 8 equals 2 plus 2, which is 4 plus b. Alright, and we combine like terms. So c equals 4. Nice. And now we're just going to plug in for the 4, whenever we said with the y. Correct. Alright, so we got the 1 for 2, and now we're just going to set up so we can plug in that 4.
Alright, so got to get rid of this 2, so we're going to multiply everything by 2. And when we do, that becomes 8. Okay? Just doubled everything, basically. So now we've got to solve for y. So we're going to take the square root of both sides. So all this goes inside the square root. And we get x squared plus 2x plus 8. And we have plus or minus, right? So which answer do we need to stick with? Y is positive in this case, right? So we're just going to say that it's y equals positive x squared plus 2x plus 8. Okay. And I think that answer. So let's see. We'll stop it for now, and I'll try to load this one up, and we'll get... Hey!